Just a second. I'll just start the recording for this class. Is the screen visible?
Yeah.
Okay. I hope the screen is visible to you.
Yes, ma'am.
Okay, okay. So, first of all, good morning. And
Morning, ma'am.
I would like to apologize first of all because couldn't be able to take the class on Tuesday. There was some medical emergency at my home, so that's why I needed to postpone this session.
No issue, ma'am.
Okay, and one more thing, because next week we are having, I guess, when is your exam? May I know that?
It's 30.
It's on 30th, right?
Mm.
Okay, okay. So that will be fine. So I'll take one class on, I guess, next Tuesday, and then come this coming Tuesday, that is day after tomorrow, and then on the next Tuesday, that is on the next week, we'll have our last class, that is of week 12. And I'm also planning to take one revision class that is of like that will be of 1 hour only. And in that, I'll try to cover this whole syllabus, like whatever the important topics that we have discussed now. So I'll just quickly try to have some questions. Maybe we can solve your last year's question paper, last year end term question paper. We can
Mm.
solve it in the class. So that will be a quick revision and also a practice sort of session.
That's
In,
very fine.
and if you guys have any doubt or any kind of any kind of numericals or any other problems, then we can take that in that class only in last week of your session. Okay.
Sure. Mm.
So let's start with today's session. Today we'll have some numericals. This is your weekly tutorial session for week 10. I'm Jia Verma, a PhD research scholar from the Department of Civil Engineering. And so let's begin with your assignment for week 10. We have some questions, some, I guess, 3, 4 numericals are there. And apart from that, some basic multiple choice questions that we used to do in previous weeks. The same thing is with this week also. So first of all, the question is like this only. The first question is, find the collecting plate area in a horizontal flow single stage electrostatic precipitator ESP that is handling an average gas flow of 3.1 meter cubes per second from a pulverized coal fired boiler. The required correction efficiency of ESP is 98%, and the drift velocity is given as omega is 15 centimeters per second. So these are the options that are given. So what do you think? What will be the approach to solve this kind of question? Any idea you have, or we'll just should we just quickly jump into the solution?
No, ma'am. I am very weak in numericals.
Okay, so no issue. There's nothing like that. I'll tell you how to solve this kind of questions. Then we can move forward now. Okay, so coming towards the solution. See, you can see this equation that we have here. Just a second. Uh, so what's happening? Mm, close. Can I get this highlight sign? पेन किधर गया मेरा? Sorry. PDF. Just let it be. Anyway, okay, so I'll just highlight this one. This equation you're seeing now. Ah, I guess I won't be able to use my pen today. Anyway, okay, so this equation that you're seeing here now, this
Yes,
eta,
ma'am.
this efficiency equation, eta is equals to 1 minus e raised to power minus a omega by q. Okay. So in this equation, what is given in the question? Let's see. They have given us the efficiency, that is 98%, right? This efficiency. What else they have given? They have given as gas flow, which is 3.1 meter cubes per second. And also the value of omega is given, that is 15 centimeters per second, right? So they have given efficiency is 98%, this value. Omega is 0.15 meters per second, this value. Just a second. This will be in meters per second. This is now, this will not be centimeter, this will be as meters per second. There's some correction here. It will be in meters per second. Okay. What we need to find? We need to find out the available collection area of the plates. That is A. And the discharge Q is given as 3.1 meter cubes per second. So we need to find this value of A, and we have the value of eta, omega and q, right? So in this equation we have three known values and one unknown. So just what do we need to do is just put the values. Now I will tell you how to do that. In this equation, put the value of eta is 98%. We can write is this as 0.98, right? Rumpa, if you have any doubt in any step now, you just stop me there and ask me that how is it done. Okay.
Okay, sure, ma'am. Sure, ma'am.
Okay, so we'll put the value of efficiency at 0.98, right? 1 minus e raised to power minus omega is 0.15, right? zero point 0.5 multiplied by the area of the plate divided by q. What is q here? Q is 3.1. Now what we'll do is we'll just shift this value to the right hand side and take it to the left hand side. So what we'll be having is this e raised to the power minus 0.15 into a by 3.1, that will be equals to 1 minus 0.98. That is one way of solving this question. Getting how to do that? Just shift this value of now this whatever this term is on the right hand side now, e raised to the power whatever is this, take it to the left hand side and 0.98 will come to the right hand side. So 1 minus 0.98 will be equals to e raised to the power whatever this value is there. And then we'll take antilog because this is e raised to the power. So we'll just take antilog of these values. On solving, we'll have minus 0.15 into a by 3.1. That will be equals to antilog of 1 minus 0.98. That will be equals to antilog of 0.02, right? And when we solve that now, we'll get the value of a as 80.85 meters square. Try to do it. Do you have any scientific calculator with yourself?
Right now, I have no, but I have.
Can you please get it because I would like you to solve this question with me only.
Okay.
Just take your calculator now. That way you'll be able to understand what I'm telling to. trying to tell you now.
So, ma'am, it's needed a scientific calculator. It's must, no?
Yeah, because how will be able to calculate this anti-log? Can you do it on your phone also? No, I guess you can do. I guess we can.
मैम एक्चुअली मैं क्लास कर रही हूँ अभी मोबाइल पे, तो मैं लैपटॉप ऑन करती हूँ। ये वाला क्वेश्चन हम फिर बाद में सॉल्व करेंगे।
Okay, okay, okay. We can do that also. Otherwise, हाँ हम फोन पे भी कैलकुलेटर यूज कर सकते हैं,
तो क्लास चलने से वो यूज कर सकते हैं क्या?
या क्लास आपके बैकग्राउंड में चलेगी. जस्ट ओपन दिस कैलकुलेटर ना.
ओके, जस्ट अ मिनट मैम।
हाँ. Are you there? Rupa, are you there?
यस मैम।
Okay, so I'll just quickly tell you the values now. You understood the process. So we take this value of e raised to the power, this term now, this term on the left right hand side, e raised to power minus 0.15 into a by 3.1. We'll take that into left hand side, and this 0.98 will take that into right hand side. So this term will be 1 minus 0.98, and this term will come on the left hand side. Up to this point you understood now how to do it? Then
ठीक
only
है मैम।
okay, then we just need to take antilog on both sides. So antilog of e raised to the power something will just cancel out, and on the left hand side will be left with minus 0.15 into a by 3.1, this term, minus 0.15 into a by 3.1, and on the right hand side we'll have antilog of 1 minus 0.98. So 1 minus 0.98 will be 0.02, right? So antilog of 0.02 will be equals to minus 3.91. So this minus of 0.15, this minus will be cancelled out with minus 3 minus of 3.91, and then there's just cross multiplication, and we'll get the value of a as 80.85. uh, since today I'm not able to use my pen now, so abhi you just understand the process and try to do it on your own after the class is over. And if you still aren't able to solve this numerical now, so I'll take it in the coming week, that is day after tomorrow. Just ask me that how to do it again, then I'll be using my pen or something, and then I'll tell you how to do this. Fine.
ओके।
Okay. So the answer will be 80.85 meters squares. This value. This is 80.85 meters square. Okay. Now, coming towards the next question. Question number 2. A baghouse filter is having 30 compartments, 220 bags per compartment. It has 30 compartments and each compartment has 220 bags. And the diameter of each bag is given as 12 meters. And the length of the bag is given as 25 meters. Gas flow rate Q is given as 15 lakh meter cubes per minute. So what we need to calculate here is we need to calculate the gross air to cloth ratios. So let's see how to solve that. What is given here is Q maximum is given as 15 lakhs meter cube per minute. Given we have 220 bags per compartment and the total number of compartments are 30. Dia of bag is 12 meters and length of bag is 25 meters. So the area of one bag will be pi dh, that is area of cylinder. So pi into dia 12 into h 25. So 942.48, this will be the area of one bag. A total number of bags is 30 compartments and 220 bags in each compartment. So that will be 30 multiplied by 220 and total fabric area that will be multiplied by area of one bag. Getting this? So the total fabric area will come out to be 6.22 into 10 raised to the power 6 meters squares. Now the formula for gross air to cloth ratio is Q maximum divided by total area. So the maximum value of Q was 15 lakhs divided by total area 6.22 into 10 raised to the power 6, and this will come out to be the value of Q was meter cubes per minute. So the value will come out to be 0.241 meters per minute. This will be your gross air to cloth ratio. This is the answer now. That is 0.241 meters per minute. Right? Understood?
Yes.
If you have any doubt now, just ask me. Or shall I move towards the next question? Okay, so next question, third question is calculate the amount of calcium hydroxide, that is lime, which is needed to neutralize the HCl, hydrochloric acid, absorbed from a gas stream which is having 30 ppm HCl, that is 30 parts per million of HCl, and a flow rate of 15,000 SCFM, standard cubic feet per minute, and assuming an HCl removal efficiency of 98%. So this is the formula when lime reacts with HCl, that is twice of HCl plus 1 mole of lime CaOH whole twice, that gives out, that breaks your HCl into compounds of calcium and then chloride and gives out water. So from this equation, it is very much clear that 1 mole of lime is required for the removal of 2 moles of HCl. You can see that. 1 mole of lime, this 1 mole of lime reacts with 2 moles of HCl to neutralize it. So we were given as HCl concentration as 30 ppm, that is 30 into 10 raised to power minus 6 pounds mole of HCl, and flow rate was given as 15,000 SCFM. The removal efficiency is 98%. So the quantity of HCl absorbed in the scrubbing liquid, how do we find? So first of all, to convert this SCF standard, to convert this standard cubic feet to pounds per mole, we need to multiply this by 385.4. So 15,000 SCFM will be equals to, we need to divide by 385.4 multiplied by the concentration, that was 13 to 10 raised to power minus 6, multiplied by the removal efficiency 98%. So we'll get the quantity of HCl absorbed in the scrubbing liquid, that will be equal to 0.00114, and for that the amount of lime required will be divided by 2, this value divided by 2, because whatever the amount of HCl we'll have, half of the amount of lime is required for that. See, 1 mole of lime is required for the removal of 2 moles of HCl. So for removal of this amount of HCl, the quantity of lime required will be half of that. So this will be equal to 0.000570 pounds mole of CaOH whole twice per minute. And multiplying this by the molecular weight of CaOH whole twice, that is 74, we'll get the value of CH whole twice required, that is 0.0423 pounds per minute, and then which is multiplied by 2.54 uh, per, to convert this into per hour, so we'll multiply this by 60, so that is 2.54 lbs per hour. This is 2.54 lbs per hour. Getting this, the amount of calcium hydroxide will be 2.54 pounds per hour. This is a very simple question, just that the units that are confusing us. Okay, coming towards the next question, question number 4. This is the, I guess this is the last numerical that we have. Then we'll have the theoretical questions. So what is the maximum toluene removal efficiency that is possible in a refrigeration type condenser operating at minus 125 degree Fahrenheit if the inlet concentration is 21,000 ppm and given the outlet partial pressure at minus 125 degree Fahrenheit for toluene is 0.018 mm of Hg. So we have given as the inlet concentration as 21,000 ppm and outlet partial pressure at minus 125 degree Fahrenheit is 0.018 mm of Hg. So assuming the outlet gas stream is in equilibrium with the toluene condensate, so the outlet partial pressure determines the outlet concentration. So we'll convert this outlet concentration into ppm, that is parts per million. So outlet concentration is 0.08 mm of Hg. So at standard temperature pressure, the Hg is converted as 760 mm of Hg, that is there, and this is multiplied by 10 raised to power 6 ppm. To convert this value into parts per million, 10 raised to power 6 से multiply करेंगे हम, so we'll get it the outlet concentration as 23.68 ppm. And to find out the removal efficiency, we'll just subtract the outlet from the inlet. Inlet concentration was 21,000 ppm. Subtract by the outlet concentration from this, that is 23.68 ppm, divided by the inlet concentration into 100. That is how we find out the removal efficiency. So that will be your 99.88%. This one, option D. Okay, so with this, we have finished out the numerical part. Now we'll have the theoretical questions. So question number 5. According to the recently published WHO Air Quality Guidelines 2021, the permissible limit of SO2 in micrograms per meter cube is given as, is it 20, 40, 60 or 80? What is the permissible limit for SO2? So let's have a look on the WHO air quality guidelines that were published in 2021. So WHO ने रिलीज किया था revised air quality guidelines on 22nd September 2021, and it was the first major update to the standards in 15 years. Like it was first given in 2006, and after that, after 15 years, the major update was done. So the revised recommendation produced from evidence-based data and information and a growing awareness resulted in nearly all pollutant standards being strengthened in comparison to the air quality guidelines established in 2005 and which were published in 2006. So basically these revised guidelines that were given in 2021, these resulted in strengthening of all the previously established standards. The guidelines were strengthened, and the policies were improvised by this guidelines that were given in 2021. So what are the components that are revised in 2021 air quality guidelines? For the PM 2.5, that is PM 2.5, the averaging time of annual average of 24 hours, the permissible limit from in the 2000. Okay, so for PM 2.5, the in 2005 air quality guidelines, the annual average was 10 micrograms per meter cube, but in 2021 it was subtracted to 5 micrograms per meter cube. The permissible limit has been reduced. For the 24 hours average, it was 25 in 2005, and it was reduced to 15 micrograms per meter cube in 2021. Similarly, for PM10, the annual average was 20 in 2005, and it was reduced to 15 micrograms per meter cube in 2021. And for 24 hours average in 2005 it was 50, and it was reduced to 45 in 2021. Similarly, the for ozone, the peak season permissible limit was added, which was not earlier in 2005 air quality guidelines. So it is 60 micrograms per meter cube, and the 8-hour average is same as previous one, that is 100 micrograms per meter cube. For the nitrogen dioxide, we have annual average as 40, and which has been subtracted to 10 micrograms per meter cube. And this 24-hour average is the new averaging time that has been added for 2021 guidelines, and it is 25 micrograms per meter cube. Similarly, for SO2, earlier it was 20 micrograms per meter cube. This one, only this one has been increased, and rest is all decreased. So this 20 has been now converted into 40 micrograms per meter cube. And this new averaging time also for carbon monoxide, that is 24-hour average, and which is 4 micrograms per meter cube. So, what is this peak season that is for ozone? So, this peak season refers to the 6 consecutive months with the highest running average of ozone concentration. That with throughout the year, uh, 6 consecutive months which have the highest value of ozone concentration will be taken as the peak season, and the value of why this value of SO2 is increased from 20 to 40 is just because the 24-hour AQG value was recommended based on a new evaluation of the effects of short-term sulfur dioxide concentration on all-cause mortality and respiratory mortality. So we evaluated the effects of this short-term sulfur dioxide concentrations, and then we found out that this value can be allowed up to a certain higher values, like that is why we've taken at this as 40 micrograms per meter cube. So the answer will be earlier it was 20, but in 2021 the value will be 40 micrograms per meter cube. Now, next question. Which of the following pollutants is not included in the revised National Ambient Air Quality Standards? Like, which of the following pollutants is not included in the revised National Ambient Air Quality Standards? So, let's see what are these NAQS.
मैम
Yes.
आप मुझे वो 5 नंबर क्वेश्चन और एक बार दिखा सकते हैं?
Fifth question.
या
This one.
ओके ओके दिस ओके डन मैम डन
Done.
हम्म
Okay. So the interest in the air quality management policies began in the India during 1970s, and after that, the Stockholm conference, which that occurred in 1972, it became that the clear that the nation was in need of a uniform environmental law. So that is why an act was passed that was known as the Air Prevention and Control of Pollution Act, that is Air Act, which was passed by the Parliament in 1981. After the Stockholm Conference, this act was passed in 1981, and with the goal of providing for the prevention, control, and abatement of air pollution, the first ambient air quality standards were adopted in 1982. This is the timeline of the different standards or the episode concepts that we have taken towards the abatement of the air pollution, or the towards the reduction of the air pollution. These standards were established by the Central Pollution Control Board (CPCB), and these were revised in 1994 and again in 2009. So these National Ambient Air Quality Standards in India were revised in 1994. They were established in 1982 and then revised in 1994 and then again in 2009. So the most recent that National Ambient Air Quality Standards that we have are for 2009. So these are the typical pollutants that are included in the national average ambient air quality standards in 1994. These were sulfur dioxide, nitrogen dioxide, suspended particulate matter, respirable particulate matter. Then we have lead, then carbon monoxide, and then ammonia. So these are the permissible limits in different type of areas. That the permissible limit would be different for industrial area, then it will be different for residential or rural areas, and the different for sensitive areas, because industrial area can have a bit higher permissible values as compared to residential, and then the residential will have higher values as compared to the sensitive areas. Basically, sensitive area will have the minimum permissible limits. So this was in 1994, and these are the values in 2009. So the pollutants that are basically the concentration is the industrial, residential, rural, and other areas. The permissible limits were same for these areas, and the ecologically sensitive area, the limits will be different by for these areas. So this earlier this bifurcation was in three parts. Now it has been converted just into two parts. The pollutants that we consider here are sulfur dioxide, nitrogen dioxide, particulate matters, that is PM10 and PM2.5. Then we have lead, carbon monoxide, ammonia, ozone, benzene, benzopyrene, and then arsenic and nickel. So the question is, which of the following pollutants is not included in the revised standards? So ozone was there, benzene was there, arsenic was there. Only cadmium is not included in the standards in 2009. So comparing the 1994 and 2009 revisions, so some of the salient features include first of the first of all we have the area classification is based on land use, so that industrial areas have to conform to the same standards as the residential areas. In 2009, the industrial and residential were clubbed together into one single unit, and the sensitive areas separated. Next up, we have the standards shall be applicable uniformly with the exception of stringent standards for NO2 and SO2 in the ecologically sensitive areas. The standards will are almost same for the ecologically sensitive areas, just as just the difference is the annual average for NO2 and SO2 are different. The previous standards for residential area have been uniformly applied for fine particulate matter PM10, carbon monoxide and ammonia. More stringent limits for lead, SO2 and NO2 have been prescribed even for residential areas. Like for sulfur dioxide, nitrogen dioxide and lead. The the values for the residential areas have also been reduced, that are more stringent values are taken there. That is annual average, you can see it has been reduced from 0.75 to 0.5 only. For nitrogen dioxide, the earlier it was 60 and now it has been reduced to 40. Similarly for sulfur dioxide, earlier it was 60 and now it has been reduced to 50. So more stringent limits have been applied for these pollutants. And earlier the suspended particulate matter was there, no size description was there for like what will be the size of the suspended particulate matter that we are considering for this guideline. Now in the revised guideline, that is in 2009, the suspended particulate matters, we have the size of the particulate matters as 2.5 microns, that is PM 2.5. And also for PM10 is also added, like you can see here suspended and respirable particulate matter is there, and here we have PM10 and PM 2.5, that is clearly described the size of particulate matter that we're taking. And some new parameters like ozone, arsenic, nickel, benzene, and benzopyrene have been included in the revised guidelines. Earlier, these pollutants were not included. Now, these also have been included in the revised guidelines. And then standards for short duration, just 1 to few hours, have been set to reduce peak exposure to some deadly gases like ozone and carbon monoxide. Like for ozone and carbon monoxide, we have some short-term standards also, that is 8 hour and 1 hour 1 hour values. Okay, so coming towards the next question. Which of the following acts is considered as the first act or regulation that is enacted to address the issue of air pollution? Which is Bombay Smoke Nuisance Act, Bengal Smoke Nuisance Act, Motor Vehicles Act, and Factories Act. So, the legislations and regulations for air quality management components, these serve as a foundation for national enforcement of air pollution mitigation efforts and the reinforcement of air quality management plans. The legislations enable citizens to establish the processes for monitoring, enforcement, and public participation in the air pollution control, which could have significant impacts on improvising the air quality. So this is the timeline, like in which year what kind of legislation or regulation has been passed. So in the year 1905, the Bengal Smoke Nuisance Act was passed. In 1912, Bombay Smoke Nuisance Act was passed. 1939, Motor Vehicles Act was there. 1948, Factories Act was there. In 1951, the Industrial Development and Regulation Act was there. 1952, the Inflammable Substances Act was there. 52, the Mines Act. 62, the Atomic Energy Act. And 63, the Gujarat Smoke Nuisance Act. So, the first act that was there was Bengal Smoke Nuisance Act, and it was in 1905. This one, Bengal Smoke Nuisance Act. It was in 1905. And after that, in 1981, that this is the national level of act that was taken in the country, that is Air Prevention and Control of Pollution Air Act in 1981. After that, we have the EPA, that was in 1986. Then National Environment Tribunal Act 1995, 97 National Environment Appellate Authority Act, 2000 Ozone Depleting Substances Rules, 2010 National Green Tribunal Act, 21 Commission for Air Quality Management in NCR region, National Capital Region, and adjoining areas. This commission is the recent one, that is in 2021, and after that in 2022 draft notification for e-vehicles in NCR was there. So the Bengal Smoke Nuisance Act that was there in 1905, at a time when there is growing concern about protecting the Victoria Memorial Hall. This is the Victoria Palace that is in Bengal. It was built between 1906 to 1921. So it was degrading due to the increased air pollution in the Bengal region. So the Britishers introduced this Bengal Smoke Nuisance Act in 1905, and this act was aimed to protect the monument from the air pollution. The West Bengal Pollution Control Board (WPCB) and the Victoria Memorial Hall, Kolkata, arranged for a ceremonious meeting to mark the centennial of the Bengal Smoke Nuisance Act in 1905, and it was framed in 1905 for the abatement of nuisances arising from the smoke of furnaces or fireplaces in the towns and suburbs of Kolkata and in Havda and other areas of Bengal. Basically, this act was framed to reduce for the abatement of the nuisances, that is the for the reduction of the or the prevention of the pollution that was being created due to the smoke which was being released from the furnaces or the fireplaces, either used in the industries or in the households, and which had an impact on this Victoria Memorial Hall. According to this act, if a smoke is emitted from any furnace in greater density or at a low altitude or for a longer time than is permitted by rules made under this act, the owner of the furnace shall, on conviction, be punished for the first offence with a fine which may extend to rupees 2000, and for a second or subsequent offense with a fine which may extend to rupees 5000. So these are the kind of penalties or punishments that were given, that to the person whoever is creating the pollution, that if the smoke is emitted from any furnace, if it is greater in density, or it has been or it is being released at a low at some lower altitudes, then a fine of the first time fine was about 2000, and again if second time the same problem is found, then the fine up to rupees 5000 have been levied on the person. Then this act was repealed in 2018 as it was no more relevant due to enforcement of the Air Act. So this act came into this act was founded in 1905, and it was carried on till 2018. So the next question. According to the notification for e-vehicles for NCR in 2022, the Transport Department, Government of NCT of Delhi is directed to ensure that all the aggregators and delivery service providers should adopt electric vehicles, two-wheelers in the proportion of dash within 31st March 2023. एनसीआर में 2022 में एक नोटिफिकेशन रिलीज किया गया था, ट्रांसपोर्ट डिपार्टमेंट को बोला गया था दैट दे हैव टू इंश्योर दैट ऑल द एग्रीगेटर्स एंड द डिलीवरी सर्विस प्रोवाइडर्स they should adopt the electrical vehicles, two wheelers, that certain proportion was given for two wheelers and four wheelers as well. So what are those proportions? Let's see that. So basically, what is this Commission for Air Quality Management in NCR region that was published in 2021? So the an act to provide for the constitution of the Commission for Air Quality Management in NCR regions for better coordination, research, identification, and resolution of problems surrounding in the air quality index and for matters connected to therewith or incidental thereto. Basically, this act was formulated in 2021 to deal with the increasing levels of pollution in the NCR region. We all are very much familiar with the increasing of pollution in this Delhi NCR region and its nearby areas. So this act was there to ensure better coordination and to ensure better research and identification resolution of problems in the area with respect to the air quality index values. So, what are the objectives of this act? First is planning and execution of a program for the region for prevention, control, and abatement of the air pollution. Then, laying down parameters for the quality of air in its various aspects. Then laying down parameters for emission or discharge of the environmental pollutants from various sources whatsoever that have implications on air quality in the region. So these are the objectives of this act. Basically, with the formulation of this act, the guidelines were improvised and better prevention control measures. This was aimed to take better prevention and control measures to reduce the air pollution problem in the NCR region. Restriction of areas in which any industries or operations or process or class of industries that have implications on the air quality in the region shall not be carried out or shall be carried out subject to certain safeguards. Basically, some restrictions were also imposed in the areas which have certain industries, then carrying out and requiring investigations and research relating to problems of environmental pollution that have implications on air quality in the region. Basically, some investigations were also carried out for the areas which have severe values of the air pollution, that are higher values of air pollution, which are being observed in certain areas. So some investigations were also carried out in those areas, and preparation of manuals or codes is also there, and some guidelines have been formulated related to the prevention, control, and abatement of air pollution in the region. Now, what is this draft notification for e-vehicles in NCR region, which was formulated in year 2022? So, the prioritization may include early electrification of the public transport. Basically, in Delhi NCR region, you can say that a huge number of public transport has been electrified. Every public bus that you see, that is now electric in Delhi area, and paratransit, feeder service, large delivery fleet, and vehicles owned by the government, being high mileage vehicles, these all have been electrified. Then we have mandated a certain percentage in respect of the vehicles mentioned. That is, some percent of the total number of vehicles will be electrical vehicles. Enhancement of this percentage in the medium term and long term plans. This percentage is can be increased in the medium and long term plans. Then mandate a percentage for public vehicles, including auto rickshaw, buses, feeder services, government vehicles, delivery fleets, and this percentage will be high as compared to personal vehicles. So all the delivery services providers, these are they are they have been instructed to adopt electrical vehicles in terms of induction in the new onboarded fleet. And for example, within the 3 months they should have at least 10% of total number of vehicles should be electricals, total number of two wheelers should be electrical, and total 5% of the total number of four wheelers must have been electrified. And within 31st March 2023, this number should be increased to 50%. That is, 50% of total two wheelers that they have should be electrical, and 25% of total number of four wheelers should be electric. And this was done with the purpose of reduction of the air pollution problem in the Delhi NCR region. So here it is, within 31st March, the 50% of two wheelers should be electrified in Delhi NCR region. This will be the answer. Okay, so coming towards the next question. The Ministry of Road Transport and Highways, MORTH, decided to move directly from dash emission standards by 2020. Uh, let's see. These emission standards, what are these emission standards? Basically, the emissions that are stack emissions and tailpipe emissions. So some release limits have been set, and which are usually measured directly at their sources. These are termed as the emission standards. And these sources, what are the sources for these emissions? These include your tailpipe emissions that are from cars, trucks, stack emissions from the factories and the power plants, and general air emissions from domestic sources. So the what are the emission standards in India? Basically, the emission standards are governmentally promulgated limits on the emission of a pollutant from a process, and India have initiated to follow emission standards through the Motor Vehicle Act of 1988, and the standards for petrol vehicles from 1991 and for diesel vehicles from 1992, and started to follow the Euro emission standards as a reference from the year 2000. So this is the timeline for the nationwide implementation of the various stages of emission standards all over the India. The emission standard Bharat stage for India 2000, BS1 was taken from Euro 1 emission standards as a reference. For BS2, Euro 2 was the reference. BS3, for BS3, which was adopted in 2010, the reference was Euro 3. BS4, which was in 2017, the reference was Euro 4. And for to BS6, that was in 2020, the standard reference standard was Euro 6. So in 2020, government directly jumped from BS4 to BS6 emissions. That was BS4 in 2017, BS6 was in 2020. Now, the last question for this session. The National Clean Air Program, NCAP, launched in 2019, targets to reduce 20 to 30% of PM 2.5 and PM10 concentration by 2024, keeping dash as the base year for the comparison of the concentration. Which year is taken as the base year? Let's see, for the NCAP. So, what is this NCAP? It is National Clean Air Program, NCAP. So, the Ministry of Environment, Forest and Climate Change, MOAFCC, it launched the National Clean Air Program, NCAP, in 2019, and under the Central Sector Control of Pollution Scheme as a long-term time-bound national level strategy to tackle the air pollution problem across the country. And this the standards were set throughout the country for 23 states and union territories were included. 122 non-attainment cities were there. 92 action plans were submitted as of now, as of 25th November 2019, and 18 non-attainment cities in Maharashtra were identified. 4711 total number of action points were listed in the action plans. The goal of NCAP is to meet the prescribed annual average, the ambient air quality standards at all the locations in the country. The tentative national level target of the tentative national level target of 20 to 30% reduction of PM 2.5 and PM10 concentration by 2024 is proposed as under the NCP, and keeping 2017 as the base year for the comparison of concentration. So we have taken 2017 as the base year, and by 2024 we aim to reduce the emissions of PM 2.5 and PM10 by 20 to 30%. It is a midterm 5-year action plan to begin with the keeping 2017 as the base year. And this program may be, if successful, then this may be further extended to 20 to 25 years in the long term after a midterm review of the outcomes. And the overall objective of the NCAP anticipate the comprehensive management plan for the prevention, control and abatement of air pollution, besides augmenting the air quality monitoring network across the country. And this plan aimed to collaborate between different relevant central ministries, the state governments and the local bodies. A proper collaboration is established between these bodies to ensure that the standards that we have set for different areas have been achieved in those areas, those attainment and non-attainment cities. Mainstreaming and integrating the existing policies and programs, including the National Action Plan on Climate Change (NAPCC) and other initiatives of the Government of India. And these use the Smart Cities framework to launch the NCAP in the 43 smart cities, falling in the list of the 122 non-attainment cities. We have also used the like for the cities that are described as the non-attainment cities, we have taken the smart cities framework, and NCAP is launched there to formulate guidelines in such a way that these non-attainment cities can be converted into the attained cities, and the pollution levels are within the permissible limits in these areas. So the base year is 2017 for this question. The base year will be 2017. So that's all for the questions for today's class. If you have any doubts, you can ask them. Do you have any doubts for today's class?
मैम आई हैव ए क्वेश्चन।
Yes, Trumpa.
मैम ये जो अपने जो भी क्लासेस लेते हैं ना आप लोग, तो उस
Yes.
तो रिकॉर्ड करते हैं ना, वो सब बाद में मिलता है, हम क्या एक्सेस कर
Yeah.
सकते हैं क्लासेस?
Yes, we have different spreadsheets ना, उसमें हम इन सारे रिकॉर्डिंग्स को हम यूट्यूब पर भी अपलोड करते हैं। अपार्ट फ्रॉम दैट वी हैव क्रिएटेड अवर ओन ड्राइव्स। तो उस ड्राइव फोल्डर में ये सारी पीडीएफ जो भी हमारे पास में क्लास में हम क्रिएट करते हैं, जिस भी पीडीएफ से हम पढ़ाते हैं, वो पीडीएफ्स एंड ऑल द रिकॉर्डिंग्स ऑफ द क्लास, वो सारे वहाँ पर प्रेजेंट रहते हैं।
दिन में ट्राई किया था तो खुला नहीं है। आई थिंक देयर इज सम टेक्निकल इश्यूज मे बी।
ओके, तो मैं ऐसा कर सकती हूँ कि मैं क्लास के बीच में, अभी तो आई डोंट हैव माय सिस्टम, बट इन द नेक्स्ट क्लास, इन द लाइक डे आफ्टर टुमारो ऑन ट्यूसडे ओनली, तो मैं वो ड्राइव का लिंक शेयर कर दूंगी इन द चैट बॉक्स। तो आप डायरेक्टली उसको एक्सेस कर सकते हो, और वहाँ पर सारे रिकॉर्डिंग्स एंड प्रेजेंटेशंस आर अवेलेबल।
ओके ओके, दैट विल वेरी हेल्पफुल फॉर अस।
श्योर श्योर, वहाँ पर मैं सारे क्वेश्चंस अलॉन्ग विद द सॉल्यूशंस, एवरीथिंग इज देयर।
मैम यू टेक लॉन्ग और सम जिंजर्स इन योर माउथ, इट विल हेल्पफुल।
Yeah, thank you so much. Yeah, I'm having severe cough, and I think it's about 1.5 months that I'm
या
having it.
आई मैंने भी सम 2 to 3 months,
Yeah.
3 months से वो
Okay.
लग रहा था, तब खुद भी काम नहीं कर रहा था उस टाइम।
Okay.
Lots of scars, everything.
Yeah, I think it's some kind of
What
flu that
what
is
should I
there.
buy?
I'm having this from, I guess, in from February only. The मतलब जब से मैंने क्लास लेना स्टार्ट किया है, I
हाँ,
have this problem. So I guess I'll do that also. I'll try that. Thank you for your suggestion. Thank you
फिर
so much.
आप वो गर्म पानी कीजिए और गार्गल कीजिए।
Yeah, yeah. Thank you so much, Rompa. That's so kind of you. Thank you. अच्छा, अभी कोर्स में आप लोगों का कैसे चल रहा है? Are you able to like understand the concepts that are being taught in the class, or are you having any doubts or anything that you're not able to understand any
क्लास
topic?
ही है अभी, जो लास्ट वीक चल रहा है उसमें जो सब जो इंस्ट्रूमेंट दिखा रहा है ना,
Yes.
के बारे में अगर हम कुछ रिवीजन कर सकते हैं, हम जब देख रहे हैं ना सेम इंस्ट्रूमेंट को, हम देख सकते हैं और एक बार, या फिर आप थोड़ा बहुत अगर ऐसा कुछ
या
पॉसिबिलिटी।
डेफिनेटली मैंने उन इंस्ट्रूमेंट्स को यूज़ भी किया हुआ है। तो मैं आपको उनका वर्किंग, उनका प्रोसेस, या मेरे पास जो भी डेटा अवेलेबल है कि किस फॉर्मेट में उनकी डेटा शीट होती है, मैं वैसा कुछ क्लास में भी ले सकती हूँ।
तो बहुत ही अच्छा होगा, वो हेल्पफुल होगा बहुत, क्योंकि ये सब इंस्ट्रूमेंट्स एक्चुअली अगर हम खुद करते हैं ना लैब में जाके तो बहुत
या
अच्छा, लेकिन वो तो
हाँ,
अभी
डेफिनेटली लैब में अगर आप खुद से प्रैक्टिकल्स परफॉर्म
हाँ,
करते हो, आप डेटा खुद से कलेक्ट करते हो, तो वो तो डेफिनेटली बहुत हेल्पफुल रहता ही है, और वो इजीली आपके दिमाग में बैठ जाते हैं वो कॉन्सेप्ट्स। और सिर्फ देख करके विजुलाइज करके समझना वो थोड़ा सा डिफिकल्ट होता है। आई कैन अंडरस्टैंड दैट टोटली।
actually मैम I completed my MSc in the time of lockdown, so
Okay.
I am
Okay,
glad.
I'm getting same was with me also. I completed my MTech in the lockdown only. तो जो भी लैब के इंस्ट्रूमेंट्स या जो भी चीज़ें थी, लाइक आई स्टिल आई वाज फॉर्चुनेट दैट आई कंप्लीटेड 1 year ऑफ माय मास्टर्स बिफोर द लॉकडाउन. So that's why at least मेरे को लैब का थोड़ा सा हिस्सा, एंड आई कुड अंडरस्टैंड हाउ दीज इक्विपमेंट्स वर्क.
मेरा तो
बट
2 साल
ड्यूरिंग माई,
कोरोना
या
में भी नहीं
या
था।
तो बहुत डिफिकल्ट होता है, बिकॉज नाउ आई अंडरस्टैंड ना कि जो जिन स्टूडेंट्स को लैब का एक्सेस नहीं मिला है, उनको प्रोजेक्ट्स में कितने प्रॉब्लम हो रहे थे. एंड ऑल्सो उसके बाद में भी अभी कंसेप्ट समझने में डिफिकल्टी होती है, बिकॉज ऑनलाइन वी ऑल नो कि कितना ही समझ में आता है ऑनलाइन. हाउ मच इज देयर, एवरीवन इज नोइंग.
Preparing for CSC, maybe next
ओके.
year the advertisement will come. Then that's why I am very afraid for that. अगर वो
No,
लोग
no, no. Don't, you don't need to be afraid for anything. Just focus on your concepts. जो भी doubts are as far as this subject is concerned, or if you need like help on any other topic as well, you can just message me personally also. You can take my email ID or anything. Uh, I can help you out if I know anything, and then I'll definitely help you out.
okay, okay, ma'am. Ma'am, please, your phone number, your WhatsApp number or email.
I'll just share my email ID in the chat box only, no? Where's the chat box? Just a second now. Okay. Mm, the system is slow.
चैट बॉक्स में ना चैट
I'm just typing there. Actually, the system is very slow. So, trying. Okay. I've shared my email ID in the chat box only. I hope you all got that. तो आपको अगर कोई भी क्वेरी होती है इन एनी क्वेश्चन और एनी न्यूमेरिकल और एनी कंसेप्ट दैट यू हैव एनी क्वेरी, तो आप मुझे ईमेल कर सकते हो, एंड देन आई ट्राई टू टेक दैट टॉपिक और टेक दैट क्वेश्चन दी नेक्स्ट क्लास. और इफ वांटेड आई कैन टेक अ सेपरेट क्लास और टेक अ एन एक्स्ट्रा क्लास फॉर दैट एज वेल.
मैम आपका वो चैट में कुछ नहीं मिल रहा है।
व्हाट?
अब आपने जो शेयर किया ना अभी,
या
वो नहीं मिल रहा है, दिखने में नहीं मिल रहा है।
ria_v@ce.iitr.ac.in.
रिया अंडरस्कोर
V, that is V for Verma. Ria_V at the rate ce
CE
dot iitr dot ac dot in.
IITR
Yeah,
.ac.in।
yeah.
चैट बॉक्स नहीं दिखा रहा है मेरा इधर, डिसेबल्ड
Uh,
है ये वाला बटन, दैट्स व्हाई।
maybe due to this, some policies are there. I don't know what's happening.
एक्चुअली
Anyway,
I have lesser knowledge about tea.
it's all right. It's all right. You just you have you written my email ID now? आप मुझे
Riya,
डायरेक्टली आप मुझे
okay.
डायरेक्टली ईमेल कर सकते हो, और मैं वहाँ से ले लूँगी आपके जो भी डाउट्स हैं, जो भी टॉपिक्स पे आपको क्वेश्चंस हैं, एनीथिंग इफ़ यू हैव.
मैम आप कहाँ से हो, कहाँ रहते?
रूपा, बेसिकली आई एम फ्रॉम उत्तर प्रदेश, यूपी में हूँ मैं। और अभी राइट नाउ आई एम परसुइंग माय पीएचडी फ्रॉम आईआईटी रुड़की। ओके, सो आई गेस अभी 1 hour 16 minutes की क्लास हुई है। कुछ
हाँ।
टॉपिक अगर आपको चाहिए हो तो आई कैन टेक दैट। और असाइनमेंट क्वेश्चंस, इस वीक का असाइनमेंट आई होप हो गया होगा आप लोगों का।
नहीं, 12 अभी बाकी है।
ओके, वीक 12 इज लेफ्ट, वीक 11 इज डन, डन राइट? योर एग्जाम, you're sure ना योर एग्जाम इज ऑन 30th राइट?
मैम अभी तक कुछ नहीं आया, अभी तक मेल।
अच्छा, मेल नहीं आया है।
हॉल टिकट नहीं है अभी तक।
ओके, लास्ट क्लास कब है आपकी? कब तक क्लासेस चलेंगी? लास्ट डे ऑफ द क्लास इज व्हेन डू यू हैव?
इट्स ट्यूसडे, वेडनेसडे, the last submission date for our 12 week assignment and
ओके,
complete.
दिस वेंसडे और द नेक्स्ट वेंसडे?
And this Wednesday.
This Wednesday. Okay, let's see. Rumpa, whenever you get the mail for your examination date now, you just forward that details to me on my email ID now, because I need to take 2 classes before your examination, and along with that one extra class. So maybe in the next week we'll have to cover that only.
मैम अभी ट्यूसडे वेडनेसडे को अगर कंप्लीट हो जाता है हमारा कोर्स, तो उसके
Yeah.
बाद अनाउंसमेंट में जो जो हम लोगों को जो लिंक्स आते हैं, तो वो शायद वो खुला रहेगा या बंद हो जाएगा? क्योंकि आप।
आई गेस अनाउंसमेंट्स ओपन रहेंगी,
अच्छा।
बिकॉज जब तक आपके एग्ज़ाम नहीं हो जाता है, एंड टर्म एग्ज़ाम के बाद में ही अनाउंसमेंट्स क्लोज करेंगे। बिकॉज अभी क्लासेस चल रही हैं, वी हैव टू टेक 12 वीक्स क्लास ना, तो अभी हमारा 10th वीक कंप्लीट हुआ है।
हाँ हाँ हाँ।
तो 12 वीक्स के बाद में ही अनाउंसमेंट्स बंद कर सकते हैं, बिकॉज क्लासेस का भी अनाउंसमेंट आपको वहीं पे ही मिलता होगा।
हम्म। मैम वो जो सब इंस्ट्रूमेंट है ना, बैग
हाँ
हाउस, फिल्टर हाउस, इलेक्ट्रॉनिक प्रेसिपिटेटर, उसके बारे में आप थोड़ा बहुत अगर डिटेल्स में बोल देंगे तो बहुत अच्छा है।
हाँ, ठीक है। कभी जानना है आपको? अभी करना है या फिर नेक्स्ट क्लास में करना है? जैसे वट
न्यू
एवर योर कंफर्टेबल।
न्यू।
ऑन मी। ओके, वी कैन टेक, ठीक है, 1 or 2 टॉपिक्स हम अभी ले सकते हैं।
ठीक
और
है।
उसके बाद मैं स्लाइटली तुमको वर्किंग समझा देती हूँ उनकी, फिर थोड़ा
हम्म।
सा डिटेल में हम नेक्स्ट क्लास में ले लेते हैं।
ठीक है मैम, ठीक।
ठीक है, ओके। ESPs और बैक हाउस फिल्टर्स, राइट?
देन वेट स्क्रबर।
या वेट स्क्रबर ऑल्सो। चलो, मैं बेसिक प्रिंसिपल सबका बताती हूँ आपको, और उसके बाद फिर डिटेल में अपन नेक्स्ट उसमें जाएंगे। ठीक है, देखो, बेसिकली तुम्हारा जो इलेक्ट्रोस्टैटिक प्रेसिपिटेटर है, इसमें हमारा जो मैकेनिज्म है या जो फोर्स है जो दैट एम्स टू, पहली बात तो ये पार्टिकुलेट्स के लिए होता है। पार्टिकुलेट मैटर जो हमारी एयर स्ट्रीम में प्रेजेंट है, उसके रिमूवल के लिए होता है। तो इसमें क्या होता है, जो इलेक्ट्रिकल चार्ज होता है ना, इसकी हेल्प से हम सॉलिड पार्टिकल्स या लिक्विड ड्रॉपलेट्स को, या सम गैसेस आल्सो, उसको स्टैक से हटाते हैं। तो हटाने के लिए हम क्या करेंगे, हमारे पास एक बॉक्स होता है, ठीक है। उस बॉक्स के अंदर सर्टेन प्लेट्स लगी होंगी। जो एरिया हम निकाल रहे थे ना, ईएसपी का क्वेश्चन, फर्स्ट क्वेश्चन जो हमने सॉल्व किया थी क्लास में, वो ईएसपी का था।
हम्म।
तो उसमें जो एरिया मांग रहा था, तो वो एरिया ऑफ कलेक्शन प्लेट था। तो बेसिकली ये प्लेट क्या करती है, दीज प्लेट्स आर चार्ज्ड, ये इनके अंदर ऊपर आइदर पॉजिटिव या फिर नेगेटिव कोई एक चार्ज होगा। तो हम क्या करेंगे, जब हम गैस, इस बॉक्स के अंदर एक इनलेट होता है एक आउटलेट होता है, इनलेट से गैस आएगी, अंदर आने के बाद में वहां पर जो गैस के पार्टिकल्स होंगे उसके अंदर, जो भी गैसेस है, मतलब एयर स्ट्रीम इनलेट से आई, उसमें जो भी गैसेस प्रेजेंट है या फिर जो भी पार्टिकुलेट मैटर प्रेजेंट है, वो उसको हम चार्ज करेंगे इलेक्ट्रिक फील्ड की हेल्प से। तो फॉर एग्जांपल अगर हमारी प्लेट के ऊपर नेगेटिव चार्ज है, तो हम अपने पार्टिकल्स को पॉजिटिवली चार्ज करवा देंगे। तो उसके बाद क्या होगा, जब वो आगे पास ऑन होगी तो जो भी पॉजिटिव चार्ज प्लेट पार्टिकल्स हैं वो प्लेट्स के ऊपर जाकर के स्टक हो जाएंगे, क्योंकि प्लेट्स हमारी नेगेटिव है, पार्टिकल्स पॉजिटिव है, तो वो अट्रैक्ट होके प्लेट्स पे चिपक गए सारे पार्टिकल्स। और उसके बाद क्या होता है, जो क्लीन एयर स्ट्रीम है वो आउटलेट से बाहर आ जाती है। ये तो हो गया इसका बेसिक प्रिंसिपल।
मैम ओनली इलेक्ट्रॉनिक प्रेसिपिटेटर में ओनली जो सस्पेंडेड पार्टिकुलेट मैटर्स होता है वही ओनली स्टक हो पाएगा ना?
मेजरली यही होता है। इसके
Yes.
अलावा क्या होता है, थोड़ा सा ऑयल मिस वगैरह भी होते हैं, या
हाँ,
कुछ एसिड्स भी प्रेजेंट है, मतलब जिस भी चीज को आप चार्ज कर सकते हो वो इससे हट जाएगी, क्योंकि इसका पूरा
तो
मैकेनिज्म ही आप
के
इलेक्ट्रिक
ऊपर तो
चार्ज के
काम
ऊपर है।
नहीं करेगा,
हाँ।
गैसेस के ऊपर तो वो काम नहीं करेगा, ओनली पार्टिकुलेट मैटर के ऊपर काम करेगा।
हाँ, मेजरली पार्टिकुलेट के ऊपर ही काम करेगा। गैसेस को अगर हम कन्वर्ट कर सके किसी दूसरे फॉर्म में तो हो
अच्छा।
सकता है, अदरवाइज तो वो मेन इसका जो एम होता है वो पार्टिकुलेट मैटर्स के लिए ही रहता है। ये समझ में आ गया?
हाँ।
ओके। इसके बाद अपन आते हैं अपना बैग हाउस फिल्टर पे। तो मैं बेसिक बेसिक मैकेनिज्म समझा रही हूँ, फिर इसका टेक्निकल डिटेल जो है हम मैं नेक्स्ट क्लास में कोशिश करूँगी थोड़े वीडियोस के साथ में, या फिर नेक्स्ट टू नेक्स्ट क्लास में, जब अपन छोटी क्लास होगी ना जिसमें न्यूमेरिकल्स वगैरह ज़्यादा नहीं होंगे, तो आई विल ट्राई कि कुछ ऐसे वीडियोस ऐड कर दूँ या फिर कुछ फिगर्स के थ्रू, जिससे कि मैं थोड़ा एक्सप्लेन कर पाऊँ, बिकॉज आज मेरा लेक्चर उस तरह से मैंने प्रिपेयर नहीं किया था, आई डिडंट हैव मच टाइम। तो नेक्स्ट क्लास में डेफिनेटली हम वैसे लेंगे। तो बैग हाउस फिल्टर जो होता है ना अपना, ये अपने घर में हमने सीव देखी है, छन्नी जो हम यूज करते हैं, ये बिल्कुल उसकी तरह होता है। तो क्या होगा, एक फैब्रिक बैग्स होते हैं हमारे पास, मल्टीपल फैब्रिक बैग्स होंगे जो एक कंपार्टमेंट के अंदर फिक्स किए जाते हैं। जब एयर इन कंपार्टमेंट से पास होगी तो क्या होगा, जैसे अपन सीव करते हैं छन्नी में, क्या होता है अगर हम जैसे फॉर एग्जांपल किसी लिक्विड को सीव कर रहे हैं, तो जब हम लिक्विड को छानेंगे तो उसके अंदर जो भी पार्टिकल्स होते हैं वो सीव के ऊपर रह जाते हैं और क्लियर लिक्विड नीचे आ जाता है, राइट?
हाँ।
तो बैग हाउस फिल्टर का सेम मैकेनिज्म है। कंपार्टमेंट के अंदर से हम एयर पास ऑन कराएंगे, उसके अंदर फैब्रिक बैग्स लगे होते हैं, उन बैग्स से एयर पास ऑन होगी और जो भी पार्टिकल्स उसमें प्रेजेंट है वो बैग्स पे ट्रैप हो जाएंगे, उन बैग्स पे ट्रैप होंगे, क्लीन एयर बाहर आ जाएगी। अब इसकी एफिशिएंसी क्या होती है कि जैसे जैसे पार्टिकल की लेयर जो है वो बैग के ऊपर बनती जाएगी, तो जो पोर साइज होगा वो और छोटा होता चला जाएगा।
हम्म।
पोर साइज छोटा होगा तो एफिशिएंसी बढ़ती जाएगी। लेकिन एक पॉइंट ऑफ टाइम के बाद क्या होता है, जो प्रेशर ड्रॉप होता है ना वो बहुत ज्यादा होता है, मतलब इतनी मोटी लेयर फॉर्म हो जाएगी कि फिर एयर ही क्लियरली पास ऑन नहीं हो पाएगी। तो उसके लिए हमें क्या करना पड़ता है, फिर हमें उसकी क्लीनिंग करनी पड़ती है उन बैग्स की। जो भी डर्ट या डस्ट उसके ऊपर कलेक्ट हुई है उसको हमें रिमूव भी करना पड़ेगा विद टाइम। जब प्रेशर ड्रॉप जो है एक सर्टेन वैल्यू से ज़्यादा होने लग जाएगा, कि एयर को पास होने में ही प्रॉब्लम होने लग जाए, तो फिर हमें उसको, उस डर्ट को रिमूव करना होता है। ये होता है मैकेनिज्म आपका बैग हाउस फिल्टर का। इसके बाद जो वेट स्क्रबर्स हैं उसका बहुत सिंपल मैकेनिज्म है। वेट स्क्रबर में मैं सिंपल तुमको एक वेट स्क्रबर का बताती हूँ। जैसे एक वर्टिकल कॉलम अज्यूम करो, एक सिलेंडर है, सिलेंडर के अंदर नीचे से गैस इनलेट हो रही है, ठीक है, नीचे से गैस जा रही है और उसमें बीच में काफी सारे शावर लगे हुए हैं जो पानी नीचे की डायरेक्शन में फेंक रहे हैं। तो जैसे जैसे गैस को हम नीचे से इनलेट कराएंगे थोड़े प्रेशर के साथ, गैस क्या करेगी, नीचे से ऊपर की तरफ बढ़ेगी। जब गैस नीचे से ऊपर की तरफ जा रही है और ऊपर से क्या हो रहा है, पानी आ रहा है, तो उस पानी के साथ क्या होगा, पानी के साथ उस एयर स्ट्रीम में जो हमने नीचे से एयर स्ट्रीम नीचे से इनलेट से पास करवाई और वो एयर स्ट्रीम ऊपर की तरफ जा रही है, तो उसके अंदर जो भी गैसेज या पार्टिकल्स प्रेजेंट है वो उस पानी के साथ मिलके क्या करेंगे, नीचे की डायरेक्शन में आएंगे और जो क्लीन एयर है वो ऊपर की तरफ बढ़ जाएगी। तो ये हो गया स्क्रबिंग प्रोसेस कि उस एयर स्ट्रीम से हमने सारी चीजों को स्क्रब करके नीचे ला दिया और क्लीन एयर स्ट्रीम सबसे टॉप पर आपका आउटलेट वॉल्व होगा, उससे बाहर निकल जाएगी। ये हो गया वेट स्क्रबर का बेसिक प्रोसेस।
और एक क्वेश्चन है, व्हाट आर एग्जांपल ऑफ फ्लू गैसेस?
फ्लू गैसेस,
या
ओके, फ्लू गैसेस में आपकी बहुत सारे आ सकते हैं, SO2 वगैरह भी रहती है, नॉक्स सॉक्स, ये सारी चीजें जो है वो सारे फ्लू गैसेस में ही आती हैं। जो भी कंबशन से प्रोडक्ट्स रिलीज होते हैं ना, जैसे स्मोक जब निकल रहा है, हम कंबशन की एक्टिविटी कर रहे हैं, तो किसी भी चेम्बर से जो भी गैसेस रिलीज हो रही है ना, उसमें कुछ अमाउंट ऑफ पार्टिकुलेट्स भी प्रेजेंट हो सकते हैं, उसमें एसिडिक गैसेस भी हो सकती हैं, हेवी मेटल्स भी हो सकते हैं। जो भी कंबशन एग्जॉस्ट से रिलीज हो रही है वो सारी फ्लू गैसेस बोली जाती है।
मैम।
इसके अलावा किसी चीज़ का डाउट है? बाकी ये सारे डिवाइसेस का अगर मैकेनिज्म और प्रॉपर फंक्शनिंग आपको देखनी है, मैं नेक्स्ट क्लास में डेफिनेटली थोड़े फिगर्स के साथ में ऐड करूँगी, बिकॉज वो थोड़ा सा एक्सप्लेन करने में भी ईजी होगा। अभी वर्बली मैंने आपको कंसेप्ट बता दिए हैं। इसके अलावा वी हैव वन, हाँ, साइक्लोनिक सेपरेटर भी होते हैं हमारे पास। तो साइक्लोनिक सेपरेटर जो है वो काम करते हैं आपके सेंट्रीफ्यूगल फोर्स के ऊपर। आप काम कर लोगे तब ये करके दिखाओगे। हाँ, ओके ओके। साइक्लोनिक सेपरेटर्स जो होते हैं वो सेंट्रीफ्यूगल फोर्स के ऊपर काम करेंगे। उसमें क्या होता है, हमारे पास में एक चैम्बर होता है और सिलिंड्रिकल चैम्बर, उसके नीचे डस्ट कलेक्शन हॉपर्स लगे होते हैं। तो उसमें गैस को हम इस तरह से इनलेट कराते हैं कि वो सर्कुलर मोशन में, एक स्पाइरल फॉर्म में उस चैम्बर के अंदर मूव करती है। तो जब वो स्पाइरल की तरह मूव करेगी तो क्या होगा, उसके अंदर जो भी पार्टिकल्स है, आप जैसे फॉर एग्जांपल आप अपने हाथ में एक थ्रेड लो, उस थ्रेड के एंड पे कोई भी एक कुछ भी बांध दो, लाइक फॉर एग्जांपल एक पत्थर का टुकड़ा बांध दिया उस थ्रेड के एंड में। अब उस थ्रेड को हम रोटेट कर रहे हैं, ठीक है, अपना हाथ को वर्टिकल रख के उस थ्रेड को रोटेट करो, तो वो क्या होगा, एक हॉरिजेंटली एक सर्कुलर मोशन होगा उस थ्रेड पे और वो जो पत्थर है वो बाहर की तरफ भगेगा। ये तो सबने किया है ना, बचपन में हम करते थे, उस थ्रेड पे कुछ भी फंसा करके और फिर उसको घुमाते थे, तो वो क्या होता था, वो पत्थर बाहर की तरफ मोशन करता था। तो सेम मैकेनिज्म इसमें होता है, जब एयर स्ट्रीम को हम स्पाइरल मोशन में मूव करवाएंगे तो उसके अंदर जो भी पार्टिकल्स प्रेजेंट है वो क्या करेंगे, वो सिलेंडर की वॉल्स पे जाकर के स्टक हो जाएंगे। और जब उस वॉल पे जाकर के वो उस वॉल पे जाकर के जब स्टक होंगे तो फिर वहां से वो स्लाइड डाउन करके नीचे डस्ट कलेक्शन हॉपर्स में आ जाएंगे और वहां से हम उनको रिमूव कर सकते हैं। तो दिस इज द मैकेनिज्म फॉर योर साइक्लोनिक सेपरेटर्स। ऑल राइट रूपा, आई गेस आज के लिए इतना ठीक है। और कुछ डाउट है आपको जो आज हम ले सकते हैं?
हाँ मैम ठीक है।
ठीक है, तो फिर नेक्स्ट क्लास में देखते हैं, दैट इज डे आफ्टर टुमारो।
मैम वो
ठीक
तो
है,
इवनिंग होगा ना?
या
तुम ट्यूसडे को क्लास जो है इवनिंग।
हाँ, ट्यूसडे इवनिंग, ट्यूसडे इवनिंग। मैं कल वापस पहुंच जाऊंगी एंड देन वील हैव रेगुलर क्लासेस एज यूजुअल। ट्यूसडे इवनिंग फ्रॉम 6 to 8। ठीक है, ओके। ओके, टेक केयर। ओके, बाय बाय।